CLI on a cross-platform IDE for C and C++. Download now.
Hi everyone, my name is Egor, I work at Bloomberg, and today I would like to tell you why you should never compare integers and doubles unless you're very careful. Let's start with the problem. Suppose you're writing Excel, you have a column with doubles, longs, some other data mixed, and you want to sort it. So in C++, we would write std sort, pass it a custom comparator, use std visit, and we end up in a templated operator with two parameters, a and b. Each one can independently be either long or double, and then we just write a less than b. If we run this code, it works correctly. It sorts reasonable inputs, but there are unreasonable inputs as well. One of them is on the screen. So I have 4 values. V0 is strictly less than V1, but then things get weird. V1 is equal to V2 according to my comparator. V2 is equal to V3 according to my comparator. So the whole vector is actually sorted, but I also clearly has V1, which is strictly greater than V3. So I have a contradiction. It's undefined behavior to try to sort this vector using my comparator, using std sort, using std set, and there is no way you can write a reasonable algorithm that will sort this vector for you because you have a contradiction. So it's undefined behavior. It can crash, it can freeze, it can produce nonsense results, all the usual stuff. Let's investigate why v1 is equal to v2. The answer is simple. In C++, we cannot compare double and long, but what it does is implicit cast from long to double, and then compares to doubles. It's all good while our doubles are small, but once they get big enough and we have no significant digits to represent them in doubles correctly, then we get multiple longs rounded to the same double, which isn't great. What is even worse is that it is an implementation defined which double we round to, and neither of 3 major compilers tell me exactly how they do it. So what do we do next? Well, we need a better algorithm, and I propose to you 2 cases. First, up to a certain point, we get more doubles than longs, so we can convert long to double and compare without any precision loss. After a certain point, the situation is reversed. We have no fractional part in double because we have no significant digits to store it. So we have more longs than doubles. So we convert double to long and compare 2 longs precisely. So this almost works, and I have more than 2 minutes to fix all the issues with it. First issue, we actually have 3 cases, not 2. In the highlighted region, I have undefined behavior if my double A does not fit into long. And it's truly undefined. Visual Studio claims that they have some special compilation switch that controls this behavior and makes it defined. I wasn't able to make it work. So yeah, it's truly undefined. You shouldn't do it. And we can obviously handle it. We just compare A with minimal and maximal values of long. And that almost works. But again, we have the same issue. We are comparing longs and doubles. So we have implicit cast from long to double. And if we spell it out, we notice that L long max is actually not precisely representable in double at all. So it gets rounded somewhere. And no matter where it's rounded, if we take A that is equal to L long max plus 1 and compare it to L long max, then it's not compared greater than, because it's all rounded to the same number in double. So if we have this A as an input, then we get undefined behavior in our second case, which is not great. So you should be a little bit more careful. So you should round double yourself. Never write doubles that are not precise in your input, well, ideally. So I rounded it up. I also had to fix the sign a little bit so it works in a way you expect. And that is almost good. I don't like this solution because I have this long constants written down. You can make it better by using hexadecimals. I have seen this about 6 times already, and it gets prettier every time. So I guess after a few more dry runs of this talk, I will get completely used to it. But it works. It's nice. And there is one more trick that we have to do. We have to handle none, which is a special value of double, not a number. It is total nonsense. It compares equal to itself, but also not equal to itself, not equal and equal to all other numbers. So we just throw it to the back of our vector so it gets correctly sorted. Otherwise, we would get the same UB. You can also get some bonus point by exploiting that property of none and rewriting the code a little bit so you don't call this library function is none. You can also replace this constants with some numeric limits. And do some other stuff. Thank you.